Meet Haile Gebrselassie, a world champion Ethiopian long-distance runner. He was known to run in the morning, afternoon, and evening in a single day. But he credits music as one of the reasons for his success, and, well, I'll let him explain.
Okay, like this. I'm a scat man. That is the noise of the music. I'm a scat man.
So today I want to discuss exercise and music, and how music can potentially have a performance-enhancing effect. I will discuss first a brief review of the literature, the neuroscience of music. Then we'll transition into two very different but fascinating studies that explain how music is more important than you may think. So before we even discuss how music can potentially enhance your exercise, we need to first review the neuroscience of music. Now, this first paper comes from Clinical Medicine, and the authors explain very concisely the issues of music processing. The first is that there's not a single music center in the brain. This should be quite evident to us. The brain is a circuitry, and there are various parts that are occurring at the same time, and even in a hierarchical organization. So the complexity of this should not be a surprise to us. One of the consequences of this complexity, though, there are various models of music processing. Most of them used brain imaging techniques to illuminate and help establish these models. So in this paper, they presented a graph that I think drives home the message of the complexity of music processing. Now, for our purposes, we're only going to focus on emotion and the emotional aspect of music. And this is centered in the frontal lobe area. Now, more specifically, we're going to also focus on the prefrontal cortex area. The second study we'll review investigates this part of the brain specifically. So the second paper I want to look at analyzed the relationship between music and the prefrontal cortex, and it used an imaging tool known as near-infrared spectroscopy, more specifically functional near-infrared spectroscopy. So some background on this neuroimaging tool. It measures brain activity via blood flow. It's a rather small and expensive, portable, and non-invasive technology. And here's another visualization of an FNIRS with fluctuating blood flow in the brain. So now that we have reviewed the literature, let's look at our first experiment entitled Exercise, Music, and the Brain. Is there a central pattern generator? I'm sure you're asking yourself, what are central pattern generators? Well, CPGs are neural networks that produce rhythmic motor output patterns without sensory feedback. We can visualize this as neurons from the spinal network that generate patterns of rhythmic activity downward to the parts of the body responsible for movement. We can think of this in a repetitive fashion: left foot, right foot, left foot, right foot. And the best example of this repetitive rhythmic output is running. Another term we need to get out of the way is cadence. Cadence is the number of steps per unit of time. It's known that the natural walking cadence of humans is around 120 steps per minute, or 2 hertz. As a refresher, hertz is a cycle of distance over time. Now, this will be important for the hypothesis that I'll introduce in a moment. The average running cadence is known to be at around 3 hertz. And finally, an analysis of over 70,000 pieces of music showed that there was a dominant beat of 120 per minute, or 2 hertz. So with all this in mind, we can look at the hypothesis in the paper, which stated that a cadence of 3 hertz while running would be synchronized with intrinsic and extrinsic frequencies. Intrinsic frequencies being heart rate and O2 consumption, extrinsic frequencies being music. Now, they analyzed all this data using an electroencephalography, or an EEG. Now, an EEG measures electrical activity being voltage fluctuations and the flow of ions in neurons. Here we have the device that will translate these electrical activity into the EEG device, which the output being as follows. So here's an example of data output of a delta wave measured by an EEG. Notice that the x-axis is time while the y-axis is voltage. Now, the researchers measured specifically delta waves because these waves exist between the frequencies of 0.5 and 3 hertz, which was the area that was of interest for the researchers. So the actual experiment included 18 runners listening to music while they wore an EEG device. So the results are really fascinating. The data showed a strong relationship between cadence, brain waves, and preferred running music. Preferred running music included songs such as Billy Joel's Tell Her About It,
Tell her about it, tell her all your crazy dreams,
which occurred at around 2.8 hertz, and, believe it or not, this song. So, in other words, running speed, brain waves, and enjoyable music were all occurring at around 2.7 to 2.8 hertz. Now, if we reflect upon this, it's quite fascinating. Almost on a subconscious level, your body synchronized extrinsic and intrinsic frequencies. So, obviously, the next logical question is, well, how did this occur? So, they concluded that a rhythm response must be present, or an innate human predisposition to synchronize movement with musical rhythms via a CPG. The CPG is stimulated by this neural oscillation. We can think of oscillation as the following: rhythmic, repetitive patterns. And this is its representation in actual data. The main takeaways I'd like you to reflect upon include that the CPG links running style with music, and that choosing the right music tempo that corresponds to intrinsic frequencies can help improve exercise performance. Think about it that the body wants to be in tune. Synchronization is good for the body and good for exercise performance. For our second study, we're going to look at the effects of music on a 5-kilometer run. The researchers were particularly interested in how music and its time of application could affect the physical performance. This experiment included 15 male long-distance runners. Each underwent 4 experimental conditions. The experimental conditions are as follows. There were slow motivational songs during the run, fast motivational songs during the run, calm songs after the run, and the control condition, which was no music. It's important to note that the runners self-selected their own motivational songs, and it was randomly selected for which ones they would listen to. Now, before the 5K, each of the runners underwent an FNIRS test, which was used simply to confirm that an emotional response had occurred from their self-selected songs. And this follows in line with our review of neuroscience of music literature. So there are several very interesting results to discuss between the experimental conditions. So let's take Joe here. Joe ran under the fast motivational and slow motivational conditions. He would also run under the no music condition. What the data showed was under the SM and FM conditions, he would run the first 800 meters faster than without music. So, on average, between the 15 participants, runners covered the first 800 meters faster when listening to music than without. The no music produced a time of 27 minutes and 20 seconds, which was the baseline for all the other results, and we can use to compare with what the fast motivational showed, a time of 26 minutes. This result was non-significant, but it is practically significant. The difference between a minute and 20 seconds could be the difference from finishing in first place or 10th. Now the question is, why only the first 800 meters? Why not 1,200 meters? Well, if we refer back to Joe, as he was approaching the 800-meter mark, the intensity of the exercise increased and hit a certain threshold, which forced the brain to enter what is known as task switching. This mechanism is when attention is shifted from the external stimuli towards the maintenance of the intrinsic processes. In other words, in the prefrontal cortex, while you're running, the music, at least initially, may be stimulating and it may be rewarding. However, once you approach the 800 mark, at least the data shows, the effect was nullified and minimized. And finally, the researchers also looked at the vagus nerve. The vagus nerve is located in the medulla oblongata, and it regulates the heart and digestive tract. Here's a video showing that when a neuron is fired from the vagus nerve, it is sent towards, in this case, the stomach. And it has the effect of regulating and slowing down vagal activity. Now, more specifically, the research showed that during the pre-run stage, decreased vagal activity led to a decreased heart rate, which ultimately led to a more calmer and more prepared runner. We can think of an analogy as the butterflies in one's stomach, or just the general nervousness of a runner right before a marathon, for instance. Well, the research shows that music can actually be a modulating effect and can help decrease your heart rate and make you more prepared for the run. So what are the conclusions from the study? Well, we now know that music stimulates the prefrontal cortex appreciably, not just when you're listening to self-selected music, but also minutes before you engage in a run. Music is associated with better physical exertion. However, once a certain intensity threshold is reached, the brain engages in task switching and thus focuses its attention and energy on internal processes. And finally, music can have calming effects before engaging in a run. So if we reflect on this and we consider the practical applications, it should be quite clear that you should consider music as a part of your training regimen. So what does this all mean? Well, the research has shown that music should be a part of your exercise regimen. It can enhance and improve one's physical exertion. And if we return to Haile Gebrselassie, it could very well have been the difference from getting a gold to a silver.